may recognize Justin McHeffey. He is a meteorologist with Channel 4, our local CBS station. He is going to tell us a variety of things, although yesterday he was kind of preoccupied with the giant storm, and he says, I didn't have time to review all my notes. So we submitted, several of those in the e-board submitted a set of questions that we would like some answers to. As you all know, one of the things that affects being an astronomer in Colorado is something called seeing, which means a lot of the time we can't. And, because of the jet stream and various things, the undulations in the atmosphere when we look through our telescopes are larger than they are in many other places. The air is not very steady in terms of lobs of warm and cool air. One of the questions was, what is it about Colorado and the terrain that causes that? Whether he has an answer, more than we know, I don't know. There were other questions as well, but I'm just going to turn it over to Justin.
Well, first of all, thank you. I want to say thank you to Ron and Stuart and everybody here. Thank you for having me. I love astronomy. I don't know too much about it. I'm a weather guy, but I just think it's endlessly fascinating. I mean, it's endless in itself. It goes forever. And I had lunch with the board, and even just talking to you guys, I learned a thing or two, and that was really cool. So I just thank you all for having me here. It's very cool. So those are my diplomas. Started off anthropology, University of Montana. Thought I was going to be an archaeologist. I ended up being a curator. It was interesting. It was cool, but I kind of wanted to shoot myself because it was a little boring after a while. I went to get a master's in mass communication at Arizona State. That's where I learned how to talk. And then I got a certificate in broadcast meteorology from Mississippi State online. And I'm told that many of you, or at least some of you, have backgrounds in physics and mechanical engineering. So for the love of God, go easy on me. A little background in what I do, what we do. And if you happen to watch us, if you watch Channel 4, you've seen this. That's the mobile weather lab. That is essentially my office. We drive around the state and we chase storms, be it a blizzard or severe wind event or a thunderstorm or hail or yesterday's tornadoes, which I'll get into in a second. We take it all over the place. That's the guy I work with. That's Rob McClure. He's the photographer. He drives. I navigate. That particular shot was on top of Monarch Pass. Not at Highway 50 though. Actually, like on top of Monarch Crest. We took the thing four-wheeling and we got sweet wind, like 60-mile-an-hour wind. Jet stream was right overhead. It was all mixing down the mountaintop level, so it was just a screaming good day. Independence Pass. That one up on the top right is at Telluride in southwest Colorado. We actually drove the lab onto one of the ski slopes before they opened for the year. It was cool. It was a November storm in 2013, and the PR guy at the mountain was really cool. Let us do it if we want it, basically. This was Red Mountain Pass, also in the San Juan Mountain Range. Technically, well, what you can see in the background there is highway, I believe it's 550, the $1 Million Highway. And this is technically Ophir Pass, O-P-H-I-R, which scales the top of part of the San Juan Mountains and then goes into the town of Ophir. That is accessible between Silverton and Ouray. So just one of our many adventures. And then this is what we do. The reason we're out there and the reason we're doing it, we're trying to get good pictures and awareness about severe weather of all kinds. And that was a funnel there. It was last summer. Cloud to ground lightning, some radar images, lots of floods, big cumulonimbus clouds. Bottom right, probably a cloud of 35, 40,000 feet. The hail in the upper left is actually something that dented my car. I lived in North Dakota, and that was legitimate tennis ball sized hail before it melted down a little bit. And if you watched the news a couple of nights ago, we actually found baseball sized hail near Elizabeth in Elbert County. You want to talk about a powerful updraft and an amazing intensity in a thunderstorm. It doesn't get a lot stronger than that. That was near Lamar, Colorado, where the hail was covering the road. And it takes us everywhere, for better or worse, to Burlington, Colorado. No offense if you live in Burlington. All right, so I wanted to include this because, like I said, I don't know too much about astronomy. I know that I like it, but I actually got this from a website called sciencekids.com. But, you know, if I know this much about astronomy, fortunately, I know this much about meteorology, so you're in good hands. I know twice as much about that. So anyway, that literally is my understanding of the solar system, and just talking to you guys at dinner was pretty cool because I got to learn a lot about it. So what I was asked to do in the email was, you know, focus on visibility, on clarity, on transparency, and try and maybe come up with little rules of thumb that you can use for good nights of viewing. And obviously, lately, I don't know if you enjoy living in Seattle, but man, it's been so rainy.
I've lived there. I'll stay here.
Yeah, right. I mean, it's just, we're in a relentless pattern. We're in this big upper level low off the California coastline. It just keeps pumping wave after wave of moisture into the state. And because yesterday's event was so big, it's worth a mention about what happened up there in Weld County, Larimer County, Boulder County, in that area. Before the tornado warning was issued, and I'll just give you some background if you don't know what happened, we had at least 3, maybe 4 tornadoes touch down in Colorado yesterday. This was up near the town of Berthoud, also just to the north of Longmont, kind of in that vicinity. There was also one near Simla in Elbert County. Actually, they're trying to say that there were 2 tornadoes that touched down near Simla. Anyway, what we're looking at right here is before they issued the tornado warning, they being the National Weather Service. We're looking at what's called storm relative velocity. You don't see it on television too much. It's not as, you know, visually appealing, or it's not as understandable. But long story short, the Denver radar unit would be like right about here. Let's call it right about here. The red colors are winds in the atmosphere that are moving away from the radar unit. The green color is inbound winds moving toward the radar. Now, I don't need, all right, see? Way ahead of me. Like when I learned this, my head about exploded. So you guys, you know what you're doing. Anyway, that was a big signature. That was called a tornado vortex signature, a big indication of rotation within the storm. Moments later, this happened. They issued the tornado warning, and we had one on the ground for, after the assessment comes back, and Weather Service went up there today, it was probably on the ground for 20 or 30 minutes, and it was a large tornado. To have right against the foothills, it was a big storm. Quick little mention too about the inflow notch. This was after the storm, the tornado lifted. This is another signature. It's base reflectivity, so you're used to seeing this. But you're actually able to see where the air was coming into the storm, and it creates that, what is known as a rain-free base, and there's no precipitation where the air is going in, and then on the back side of it, like to the left of where Lyons is, that's the rear flank downdraft. So the air would be coming out the back of the storm, and inside the rear flank downdraft, you often get funnels and tornadoes. So even though the storm lifted, it was still ready to pop again. It was ready to drop another funnel. It didn't. We were pretty close to it, and if it did, we would have had a good picture of it. But just a couple of the pictures that were going around on Twitter yesterday. Near Longmont, big. I mean, does anybody live up there or in the area? It's kind of a haul. It's up there an hour or so away, but you know, it's big. It's a big storm. There's a big tornado.
Well, I grew up in Indiana. I've seen tornadoes.
Yeah. I mean, comparing it to the Midwest, I mean, you guys get huge wedge storms and wedge tornadoes. I was just amazed at how close it was to the terrain and how, you know, it's hard to get a tornado, no matter where it is. If it's in Indiana or Oklahoma, you've got to have every ingredient perfectly in place. And it's like, you know, chaos in the atmosphere, and there's all these different things going around, and you know, certain variables have to be in perfect sync for it to happen. And the fact that it happened right next to the mountains is interesting because the low-level wind profile is interrupted by the terrain. So that the fact that it actually was able to spin up like that was something else. Anyway, more of the tornado. Pretty cool. Some of the hail that we found, like quarters, ping pong ball size is the biggest that we found. So anyway, so anything on that? That's something else. So daily resources, things that I use, places that I go to draw up a forecast and, you know, try and, you know, be as accurate as possible, which is, God, hard sometimes. And I tell you what, lately it's just been, we've had our work cut out for us lately, that's for sure. So this is the Weather Service, great resource. I'm sure you already use it, especially if you're looking at the stars. But it's excellent. And I mean, look at today. Look at the mess. You want to talk about the epitome of a bad time to look at the sky? I'm sorry about this, but we've got a flash flood watch. We got tornado watch out east. That is an active tornado warning. This has been going on and on all day, from lifting from the cloud and going back up into the cloud. But it's just been cloudy. We're inside of that pattern. Another one, a really important one, especially for things like yesterday. Public?
Yes.
Yesterday and today, we had tornado watches. So the SPC, the Storm Prediction Center, is also a part of NOAA, and they're down in Norman, Oklahoma, and they issue these tornado watches and severe thunderstorm watches across the country. And the interesting thing about the past couple of days is, like on Wednesday, we had an enhanced risk of severe weather. So, like I was saying, ingredients coming together: low-level moisture, upper-level instability, mid-level instability in the form of vorticity, little areas of spin and lift rotating and moving through the atmosphere. It was higher on Wednesday than it was yesterday. If you remember, though, Wednesday was a bust from a forecaster's perspective. We didn't get a single tornado. So everybody that's watching is going, "You're an idiot, you guys don't know what you're talking about, you're weather guessers." I mean, after a while, you get used to being a punching bag. You don't get it right all the time. It's just the way it is. Anyway, Wednesday was a bust, but yesterday was crazy. I mean, even for Colorado standards, yesterday was a big weather day. We had several touchdown tornadoes, one of them in a pretty highly populated area. So it was just big. And the crazy thing about that is awareness, public awareness, because if on Wednesday it didn't come together, people on Thursday are going, "Oh, you cried wolf yesterday. It's not going to happen today," but then it ended up happening yesterday. And that's a crazy game to play. Anyway, these guys are tremendous. They're very smart. I've met a few of them at conferences. Some of the smartest people I've ever met. Let's see here. High Prediction Center. National Center for Atmospheric Research. Very important. And also an excellent resource for you. Do you guys use model data? Do you look at cloud cover forecast using models and stuff, like through the NCAR? Anybody?
There's a website called cleardarksky.com, and that website attempts to predict for the next couple of days what the transparency and the seeing and the overcast level in the atmosphere is going to be for the next couple of nights. It never goes any longer than that.
Okay.
They use some models and some special predictive algorithms for those particular elements developed by the Canadian Weather Service. And there's a guy named Attila Banco who put together that website, and he worked with those people. And we don't get. I think you can click on something and get maps. So basically, what it gives you is a little set of bar graphs that indicate how dark it's going to be. If the moon's up, it's not going to be as dark as it is. When the sun's up, it's not dark at all. And the transparency of the atmosphere, the basically the cloud cover, and I think wind is in there somewhere else. But those are that's what most people who look through telescopes consult that site, and it can be pinpointed to the location that you're actually going to.
Oh,
Within a few tens of miles.
that's a good deal.
But it is based on forecast models which have those specific outputs.
Right. That's great. This is so the National Center for Atmospheric Research up there in Boulder, and the University Corporation for Atmospheric Research, sort of a parent and a company, and then I think UCAR was first, then NCAR came second. Anyway, they produce model forecasts like the NAM, the RAP, and the GFS, and they're just like our lifeline. It's what we use for predicting the weather. The European model, the Euro, is also obviously very popular. That's over in Europe. But you can go on this website and many others that pull information from this website and get forecasts. I'll just quickly go into this only because of, like I said, clarity and looking up if it's going to be a cloudy night or not, if it actually gets us there. But long story short, right now the pattern is that trough. That trough is just it's the dictating force in our weather. It just is for the next couple of days, and until it moves, it's going to be giving us cloud cover, not the best sky visibility, but behind it, where there's a trough, there's always a ridge right behind it. So once that moves a bit off to the east, we'll get a ridge of high pressure building in, and then hopefully by the middle of next week, you guys will get some better shots of the stars and planets and stuff.
Hey, Justin, I think I understand what a low pressure area is and why the winds rotate around it the way they do. What exactly is a trough?
Okay, so a trough,
And I guess the opposite is a ridge.
so a trough of low pressure and a ridge of high pressure.
Okay.
And let me, and I think this will answer your question. Those are interchangeable. We'll use 500 millibar lengths. Okay. All right, so there's our trough. That's our menace. That's the reason you can't look at Jupiter. Can you even look at Jupiter right now? Is Jupiter in sight right now?
Yeah. Actually, we did on Tuesday.
Okay, good guess. So that's a trough of low pressure. You can see the upper level winds rounding the base of the trough coming up. You want to look at stars, go to Oklahoma, go to Arkansas, go to Missouri right now. But everybody under the influence of that trough is just getting pummeled with Pacific moisture. And I tell you what, you see the color of the orange and the yellow? So that's the jet max, or the jet stream maximum winds about to move over Colorado. Part of the reason that we're going to have such unstable weather, unsettled weather for the next couple of days is because the winds aloft are so fast. And when you have the upper level winds moving that quickly, especially when they're kind of like diverging and moving away from each other, it causes the air at the surface to rise. When the air at the surface rises, you get clouds and eventually storms. So if you get convergence at the surface, upper level divergence, you get big storms like the ones we've had over the past couple of days. So
a trough then is kind of like a channel of low pressure, is that correct?
the center of the low is like the center of that circle.
A little donut there.
Exactly.
Oh, okay,
Exactly.
all right,
But then the center, but just right next to it, the center of that high is where the circle is there.
okay.
So like I said, wherever there's a trough, there's a ridge not too far away. Behind that low, take a look at the ridge. So that's what you got to cross your fingers for if you want a good view of the stars. And I think by next week, this snail of a low is going to finally move off to the east and hopefully get some sunshine and some clear skies.
So is this low pressure dumping any water in California?
It's missing them a great deal. I mean, yeah,
Just here in Texas.
yeah. We're getting all of it. I mean, Arizona is even getting a lot of it too.
So when that low moves east, does that mean the Midwest and the East are gonna catch it?
Yeah. And I bet, like if it stays together, if it stays really strong, like it's been, a Colorado tornado is minuscule, but it can happen in Oklahoma. So if it stays together like that and moves 500 miles to the east, they might be dealing with a pretty severe outbreak on their hands.
So if it moves to the east, as you said, 500 miles, we're drawing moisture off the Pacific, right? If it goes over there, is that going to start sucking it up from the Gulf?
Yes. And even though, that's a great question. All right, even though it is pretty far displaced over the western United States, it still is grabbing some Gulf moisture.
I kept thinking.
Yeah. And the way you can tell, when the winds are coming out of the south on the plains in Colorado, that's all tapping into the Gulf.
Yes.
Yeah. And so the reason Oklahoma is in such a bullseye for it is it's literally like the perfect distance away from the ocean to tap into that big time maritime moisture-rich unstable air, and then it collides with the arid intermountain west air. The clash of those air masses creates thunderstorms. But we're still getting a little bit of Gulf, a lot of Pacific though. And I was also asked in the email, so why do your guys' graphics look so snazzy? That looks different than what you see on TV. Everybody in Denver, it doesn't matter who you watch 4, 7, or 9, or 31, everybody pays for a graphics package. So we go through WSI. I think everybody, that stands for Weather Systems International, I think everybody in town has WSI. Mike Nelson used to have a contract with Weather Central, but they have since been absorbed by WSI. But basically, it makes it like viewer friendly, so it takes things like that and just makes it a little bit more visually appealing and understandable. But yeah, everybody has to pay for that stuff.
You put it together, right?
Yes, and that's the beauty. And so like Denver's the perfect size market because in New York, you know, and every station's different, but we don't have we've got a union at our station, but it's not, we don't have like a producers union. So when I do when I fill in for Ed, I build everything myself. So I get to draw all the information from resources online and stuff. Because I would hate to have somebody build it for me, you know. So anyway, we get to do that. Anything on this? Anybody else interested in it? Cool. Good. Okay, and this is probably even more descriptive.
Can we go back? You had one of there was a climate prediction that you did, and I just when they're talking climate, like what is the time? How long out are they actually, or is it just? I mean, because climate is basically ag, right? I mean, climate is weather over and extended.
Exactly.
So are they using that for long-term predictions or projections, and how far out can you now accurately go?
It's debatable. We're getting better, but it seems like every time we have, you know, like a great explanation for why we had 9 days of thunderstorms, and we're in this Madden Julian oscillation. It's this perturbation moving across the Pacific Ocean, and bam, we get storms. Like every time that we get that, we're good at it. We're getting better at it. Because it's going on this, you know, we've had weather data collected accurately, let's say for 100 years. Yeah, not this much, because through geologic time, we've been around for so long, you know. We're getting better at it. 90-day climate outlooks are used pretty widely right now.
Are they?
Yeah.
That's kind of what.
Yeah.
So they're doing it.
I've got to think about that. But a good thing to remember about weather and climate is if you're going to Florida, weather is what you should wear. Climate is what you can expect. You know what I mean? So it's like, oh, it's 80 in June, or it's going to storm all day and I need an umbrella. So it's now versus over the lines. Yeah. So there's a ridge. There's a drop. Cool thing about this is I made this map last week. It nailed it. This was the European model, and it nailed this week's forecast. This is the trough. You saw the trough a second ago. That's actually what's happening now. This was from like last Thursday. And that's what I mean is we're getting better, you know? Like, we're never going to nail it. There's too many little micro environments that affect the weather, but the trends are getting a lot better. I mean, this is good. You know, that was over a week ago, and we knew that it was going to be a nasty weekend. Okay, so May. Bad time to look at the stars. It was rainy all month. We got more moisture than normal. This is an upper level wind map, a lot like the one that I showed you a second ago. And notice the date here. We're looking at May 9th. And this is on Saturday morning. And we had this trough of low pressure parked over the western United States. The next week, same day of the week, Saturday, the 16th, we had a trough in the exact same area. 7 days later, we had a trough, although a little bit less defined, in the same area over the western U.S. That's the reason we got so much rain. It wasn't the same trough the whole time, but it was like every time the weekend rolled around, it was just this crappy weather that we've been. And I'm so sorry if it ruined your golf plans. No, I hope not. I mean, I hope that that's the reason. You never know. So this is what it left us with. Normal for Denver is 2.12. We got over 5. You know, that was a lot of rain. And
How close are we to the record?
the record in Denver is, I think for the month of May, was either 8 or 9 inches. But the thing about that is they've moved the weather station. So it used to be at Stapleton. Before Stapleton, it was at like Larimer and 22nd or something, in like until the 30s. Somewhere like
I don't know
that.
why they moved it up.
That's like
Has to be at the airport.
something like that, yeah.
They ought to, do they still record from Stapleton so they actually have comparison to history?
Because your variables are changing.
Exactly, and who lives at the airport? And even over the distance of 20 miles from downtown,
It's huge.
yeah, it's huge.
It's huge. It's completely different. That's why I'm curious. Why aren't they still doing Stapleton to keep that bin data correct? Because when you move it out to DIA, totally different.
You bet.
I would have to guess, and I mean,
I know they have to have it at the airport.
that's got to
I know
be,
that's why, but I'm hoping they're still collecting the data for the correct variables at Stapleton. I don't think they are.
they're not.
They're not.
And even if they are, they're not being included in official measurements and
It's
calculations.
just gonna screw up the whole.
Right.
Seriously.
Not even Stapleton, why not just keep it at Larimer? Even if Larimer is in a concrete jungle and it's surrounded by buildings,
Correct.
at least it's in the same spot.
Aren't they trying to keep it away from the Nino Islands?
That's got something to do, because in the 30s, Denver was, tumbleweeds.
I think the answer is just there are more variables than you want to juggle.
Yeah,
If you keep it in the same place, the city goes up around, it's still going to screw up the averages.
yeah. And when you look at this, okay, so the airport got over 5 inches of rain. I don't know where everybody lives, but our weather watchers and everybody in town that I've met, people have got an inch for the month of May and 12 inches for the month of May. It's the basin average rainfall totals are it's so skewed. So, coming up with,
That's the thing, especially in Colorado. You can have weather here and you can have completely different weather a half mile away.
Yes, you can.
it's just nuts. I mean,
I live in Beaumont, and I swear I live in a desert. Okay, because I watch the weather map. It forms. It comes off the mountains, then it dissipates. It goes across Santa Fe and pummels in with rain. Yeah, and I can just watch the storms just dump. I'm like, please bring some this way.
Look
It always
at
misses.
this 4 foot of hail in, what was it, like 2 or 3 block area or something?
yeah, Federal and Alameda, Westwood, I think.
It wasn't a very big area at all. It was like a microwave.
And it might as well have been snow. It was heavier than snow,
Oh, It's the same 4 days snowstorm we had all winter, isn't it? They said 4.
Yeah, which is crazy.
Yeah.
It's a tail.
The same thing in the winter, isn't it, where you get some ski areas that traditionally get higher snowfall,
Yeah,
and some other ones gotta crank their snow.
yeah.
Yeah.
And the terrain, I mean, forecasting for mountains, y'all ski or snowboard, everybody, or some in here. Does anybody read Joel Bratt's Open Snow? Really, really skilled meteorologist, because he actually predicts well for ski areas. And man, that is so hard. It's so hard. Because if it's the Gore Range, or the Elk Range, or the San Juans, and who's intercepting the moisture first, what mountain range is forcing that air mass aloft and, basically trapping all that snow in the same area. The reason the Sangre de Cristos, if you look at a map, the reason the Sangre de Cristos, which is, southwest of Colorado Springs, was it west of Pueblo?
Yeah.
All right, the Sangre de Cristos, by comparison, gets so much less annual moisture than the San Juans, pretty much because the San Juans are catching all of it. Because they are upstream and closer to the Pacific Ocean, that air hits the 14ers and the San Juans, gets forced aloft, cools, condenses, snows like a son of a gun, and then it goes downstream and there's nothing left, and they get 2 inches in the Sangre de Cristos.
And then there's good old Palmer Divide.
Yeah,
Oh, yeah.
which the storms have loved this week, every day.
But in the wintertime, you get a blizzard coming out of the south, a lot of times it gets to Palmer Divide and goes no further.
Yeah. Do you live down there?
No.
Okay. Part of the reason that the Palmer Divide, also interesting terrain feature, it's at 6,000, 6,500 in places. So when you get afternoon storms coming off the foothills, they got elevation on their side. It's 8,000 feet. A lot of times when they move over Denver, the bottom drops out, and all of a sudden they lose 3,000 feet of elevation. When they move over the Palmer Divide, they tend to stay together because they still have another 2,000 feet or so higher than Denver. So they'll live a lot longer.
Yeah, but I've noticed, that's what happens in wintertime. You get a snowstorm coming out of the south, it chugs up to the Palmer Divide, and that's it.
Yeah.
Reams it out.
Yeah.
I live up in Evergreen, and where we live is really toward the south end and pretty high up, about 8,500 feet. And frequently, the weather is completely different than a few miles away over toward Genesee, where you guys have your cam and you broadcast that every day. What accounts for that difference? I mean, they can have blizzard whiteout conditions around Elk Meadow and Bergen Park, and we won't get any snow at all. And then vice versa.
I think that the best I can come up with is, like I was saying a minute ago, like terrain features especially.
Mm-hmm.
If the wind, if the vector winds at the surface are not perfectly upslope in your area, but they are in Genesee, they're going to get land-based and you guys aren't going to get anything. Like the subtleties in the nowcast, in the ongoing weather forecast, even the slightest 1 degree change can be the difference between a foot of snow or an inch of snow. And I know that's a very broad answer, but that's just the way it is. Because I'm sure
1 degree talking temperature.
I'm talking, it could be temperature, but I mean 1 degree, so like upslope. Upslope is a word that we use ad nauseum on television. We use it all the time. So there's the Front Range, not an artist. There's Denver. When the winds are coming in from the northeast, that's upslope. And so what that means is the air and the aspect of the mountains, which are kind of like this in the metro, it forces all the air aloft. It cools and condenses and forms clouds and snows. So I mean, if you live in Evergreen at 8,500 feet and this wind arrow is just slightly like this, it can literally be the difference between an inch or a foot. Because maybe in your neighborhood, the tallest peak around has like a south-facing aspect, like it's a more a dramatic south-facing aspect, so it's not getting forced aloft as much. Yeah.
I've also noticed that there's something about our elevation level. We can get pounded with snow and have a foot of snow and get less than a quarter of a mile around the corner down toward the canyon, and it'll be bone dry.
Yeah.
There's no precipitation at that point.
Yeah.
You just drive into it.
Yeah. If I had a good answer, I wouldn't be wearing shoes from JCPenney. I'm sorry, I don't know.
I have one more. Hail up there is very unusual, and we've had some brutal hail this spring. A couple of weeks ago, we had some that have plows out to clear the road. How unusual is it for? Is there a certain elevation level where you tend not to see hail in our weather system?
I think that, remember how I was making a big deal about the Longmont tornado, how all the ingredients need to be right? The terrain has a lot to do with it. And for a healthy and mature thunderstorm to produce hail, you need to have generally an uninterrupted wind profile. So winds at all altitudes need to be doing their thing, and they need to be continuously doing their thing. Because you've got rugged terrain, it screws up with the wind. And there's a lot of surface friction because the mountains are in the way. They don't tend to what we call produce a rotating updraft. A rotating updraft is one of the signatures of severe thunderstorm and helps the updraft and the downdraft produce the hail over time. You know.
Thank you.
Sure. Anything on this? Good. Cool. And then, so the beginning of this week started out nice. This was an upper level map for the beginning of this week before everything changed, and then that little trough turned into a big closed off low pressure system that we have right now. This is also just, like I said earlier, El Nino, warmer than average sea surface temperatures in the eastern tropical Pacific. That is a fancy way of saying there's more thunderstorms happening right now on this side of the ocean. And even though we're like more than 1,000 miles away from them, even that relative vicinity on the surface of the Earth causes some of that moisture from those storms to get caught in the upper level circulation and send storm chances into Colorado.
How many degrees of temperature are you talking, like say in the red area?
I'm pretty sure that it's a sustained, it's got to be 3 months long before NOAA declares an El Nino. And I want to say it's 2 degrees above average. And I should probably go look at that. I think it's 2 degrees above average for a solid 3 months. Does anybody, I don't know if anyone has an answer.
The water temperature.
Water temperature.
That's the surface. That's a huge amount.
Yeah.
That's
2 degrees.
Above average, yeah. I think that's correct. So, man, so sorry. There's a 90-day outlook. Sorry about that. Anybody want a road trip to Kansas?
You wanna take bets on that?
Yeah. Actually, I think I'm sorry about that. I reversed those.
Drier for us and winter.
No, it's wetter. It's going to be wetter in the Rockies. I'm sorry about that. Sorry.
Oh.
Happy that that made us.
Yeah, I know. I didn't want to break it to you. All right, so now, I'm kind of geeked out about weather and like larger scale things. This is interesting, and I think that this would apply to looking at stars and planets. Okay, I lived in LA for a summer. And Los Angeles is notorious for smog. It is notorious for smog because a jillion people live in a square mile. Obviously, a lot of pollution, a lot of low-level particulates. Part of the reason that it gets a lot of smog is because of this, like I said the word earlier, it's called a semi-permanent circulation feature. So for part of the year, there's this big area of high pressure spinning off the California coastline. And on the east side of that high, see how the windows are coming right down over Los Angeles? You have subsiding, sinking air on the east side of a high pressure system. And so not only do you have a lot of pollution, but you have a dome on top of LA. But one thing I noticed, so yes, smog, so you got kind of a dome. One thing I noticed when I lived there, this was really cool, is once in a while, yes, you've got this pretty much set up high pressure system. It's there for part of the year. Sometimes within that clockwise flow, you'll have this little upper level disturbance, just a little localized area of low pressure that moves through that flow aloft. When that happens, and it moves over LA, it literally pulls all of the air off the ground, including some of that pollution, and turns it into clouds, and it rains. The day after a rainstorm in LA, it was beautiful. It's the only time you get to see LA actually look pretty, because there's mountains and stuff. It looks pretty. I think that applies to Denver and the mountains. I think that even if we have high pressure, which is usually good, or it's going to be sunny, the day after a rainstorm, or especially the day after several days of rain, which might be the middle of next week, it'll probably look pretty good. I think it'll be pretty clear outside. Is that?
So are you saying that's gonna hold for statewide next week?
Pagosa Springs, 4:30 p.m. next Sunday. What's the
Gardner, Colorado.
Gardner for the
RMSF.
yes.
Yes.
What day of the week?
Wednesday through Sunday.
Better than right now.
Okay.
Yeah, I know. It's confidence. That's a lot of confidence. That's all you give me. Better than right now. It looks like the ridge is going to move in, and it'll be sunny.
Loonier is the case that you were starting.
Yeah. This is something too I was thinking about. You guys probably know all about this, but all right. So if you're looking at a moonrise or a sunrise, and you're looking out on the horizon, the sun or the moon looks huge. So why is that? Because it's being amplified through several layers of atmosphere. Because you're actually looking through a thicker atmosphere, and it actually amplifies the surface of the sun. And this is probably common knowledge, but it just like blew my mind when I thought like that this might be true earlier today. But if you're looking straight up on a really crystal clear night, that's probably the best position to look at a star or planet, right? You're looking through the least atmosphere.
That's right.
I can hang.
So what conditions would cause the air to be really still? Because that's what we really want. For seeing, you want very still air.
Yeah.
One of the real big problems with the observatory over here you always have this disturbed air going over. And you can actually, in the telescope, it actually looks like a river of air going through the telescope. Really? Yeah. You can actually see the air moving.
Yeah, based
So
on
what we want is very still air, because that's when.
Are you
everything's
looking,
perfect.
are you looking at like, is it like haze that's moving?
So you're actually
It's thermal.
No, I did the experiment one time. I was looking at a star fairly close to overhead with my scope at home and focused as best I could, which wasn't very good because it was a big fuzzball. And as I gradually moved the eyepiece out, all of a sudden it looked like the surface of a creek. You could actually see very sharp waves. And then beyond focus, it was fuzzy again. Knowing how far I pulled the eyepiece out, I could calculate the distance to that boundary layer, 25,000 feet. Where's the jet stream?
Jet stream.
Man.
So we were able to get that. And the other interesting thing is the moon is not any larger on the horizon than it is overhead.
Yeah.
It's an optical.
It's strictly an optical illusion.
Well,
Because of the atmosphere, because of the atmosphere.
No, because of the foreground stuff you're looking at.
Yeah.
You're getting perspective off of
Yeah.
distant buildings, trees, and whatever. And that sort of distorts your view of the size of the moon being bigger down at the horizon.
Take a photograph.
I taken photographs of the sun during a Mercury transit, and I got it all the way down, and I compared the two images. Actually, the sun flattened, but it didn't white. So it was actually smaller when it was down at the horizon.
And you're saying that's because you've got other objects to compare it to?
Yeah,
I think
That's
that's one hypothesis. There's a lot of hypotheses.
Right.
But the way you prove this is you take a long lens, like a 1,000-millimeter lens or so, photograph it on the horizon, photograph it as it goes up, and it's 1% bigger when it's overhead because you're 4,000 miles closer to it.
What you do with the school kids is you just hold up a ruler. Put your thumbs on it, on either side of the moon, and then you have them go out a few hours later.
Yeah.
They take the same ruler, hold up their thumbs, voila, it's the same distance.
Yeah.
That's what I do with my students when I do star parties.
Yeah.
When you do the nights that you do a full moon, just because the moon's so cool to look at, and they love it, you catch them right when it comes up, and just give them a compass. Say measure it, and then wait.
Yeah.
Because they'll swear it's bigger, and say measure it a couple hours later.
No, it's not.
It's so closer now.
Optically, it's about 30 minutes apart, no matter where it is in the sky.
Yeah.
But there is a refraction effect as you get down close to the horizon.
Yeah, you don't want to look at things long.
Instead of,
Especially over the mountains.
the straight line actually looks a little bit lower than it actually is.
Okay.
You can actually see slightly over the horizon because of that refraction. That's curvature of light.
Full circle. Huh.
Kind of an interesting aside. I gave a talk for some school kids using a ruler to point stuff out on the blackboard, and I asked the kids if they could use this yardstick to measure the distance to Venus. And I think all the teachers thought I'd been smoking funny mushrooms, and half the kids did. But it was just, I think what he was saying is that if you hold a stick like that at a given distance, those inches aren't inches anymore, but they're degrees or arc minutes or whatever else. And the idea I gave them was you put your thumb over the sun, you can see Venus in the daytime, and just keep measuring it until it's maxed out. And then look up the sign of that angle, distance to Venus. And I actually tried it with a cheap styrofoam yardstick, and I got within something like 5%.
Nice.
So it sort of worked.
That's cool.
Another question I had when for example, this website, cleardarksky.com, one of the bars that you can read there is transparency, and another one is forgotten what it calls it, but it's basically overcast. In other words, how much cloud cover is there?
Yeah.
I'm not sure of the difference. If you don't have any cloud cover, how is it you can get with transparency?
What's your
Humidity in
why
the
do you
air.
focus
You
website?
other observers.
Humidity in the air has a lot to do with it. Because in the Midwest where I grew up, it'd be clear, it'd be very humid. And we get out here, we can see a a lot better through the sky because the moisture in the air is much less.
Yeah, this showed up on our,
You don't see the fog, you get some scattering of light from.
Yeah, 100% humidity, you can still see through the atmosphere, but, well, actually 90%, you can still see through the atmosphere. But difference between 90% humidity and 20% is tremendous.
Well, are there actually tiny water droplets?
yeah, well, that's transparency. This showed up on our listserv. There are two things that keep you from seeing a dim star. One is transparency, how transparent the atmosphere is, clouds, humidity, and the other is the noise floor, how bright the sky is. And as Roger Clark pointed out in his talk on nightscape photography, there is a natural night air glow that can sometimes be pretty doggone bright.
Yeah.
And that's what we measure. We go up there and wave our sky quality meters around. When you get, it was Okie-Tex Star Party, 2 nights were a half magnitude apart, which is I think something like 58%. And boy, you could tell that second night the sky was definitely brighter. And both days were sapphire blue, no particulates. So you've got the noise floor and you've got the actual attenuation.
Well,
And if you've got stuff in there and you're near the city, then you're going to get all the light pollution backscattered.
when you use your sky quality meter, that's registering city lights reflected from whatever's in.
Yeah, or night air glow or scattered
And
starlight. It's just
as
basically
well
the background.
As well as the air glow from
Yeah,
reformation,
exactly.
ionized oxygen and whatnot.
Cool. Keep going.
I'm sorry. So, again, we're talking about still air.
Oh, yeah,
What would cause the air to be really still? What conditions?
that's a big help. This here is a big help. So in this case, if it's the jet stream that you're looking at, if you said there's kind of like a visible stream of air and you're looking up into it, the jet stream's overhead, it's going to do that. If you have high pressure overhead, that means the jet is going around the top of that. That's the ridge in the jet stream. So the upper level winds would be going over the top of that. So underneath the center of that high, I'm going to say, is the best for viewing.
So if there's a high, the jet stream doesn't go over it?
If there's a high, so like this is that high pressure, the jet goes like this, over the top.
Oh.
North of
As
it
soon as
or
out of the air.
above it?
Yeah, it like rides, so it rides these arrows.
So it's going north of the,
North of
the high.
In this case, the jet would be over Montana, Idaho, and North
So
Dakota.
it isn't actually going right over the high, but it's.
It's
Going
going
around
down.
the top.
Yes, yes. And
It's a peak.
yeah,
If we think of looking straight up as that's what I say, it's not going over. If you're looking straight
no,
up.
horizontal, not vertical. Yeah, I got you.
Justin, what exactly
Winds going
causes
this way.
the jet stream?
Man,
Doesn't it flow in between a cold region and a warmer region of air?
yeah. So the basis for all weather systems, the reason we have rain, the reason we have wind, is because of differential heating of the Earth's surface. The Earth is tilted. The Earth's axis is tilted. During the summer, the northern hemisphere is pointed towards the sun. During the winter, the southern hemisphere is pointed towards the sun. What that does is it causes more direct sunlight in the southern hemisphere during our winter and more direct sunlight in the northern hemisphere during our summer. Because the Earth is tilted, because you get more direct rays, it causes these pockets of higher pressure versus lower pressure. And the Earth has a tendency to try and balance out those pressure differences. And those moving across the planet is just that. It's the Earth trying to
That's
balance.
what pushes the wind, basically, is a pressure difference.
Right.
The pressure difference, yeah, pressure gradient forces is what causes the wind.
Are you
Because
talking about the top, like 5 miles up, no higher?
the jet,
No, well, all of this weather you're talking about, it's all within the top, within 5 miles up?
yes,
Yeah.
inside the troposphere, where weather happens.
5,000.
Yeah. Cool way to describe that though, like the air flowing from high pressure to low pressure. If you come home from the grocery store and you open a can of coffee and it makes that sound, makes that sound, that's literally the higher pressure in your kitchen flowing into the lower pressure in the coffee can.
And blowing your coffee grounds out.
Yeah.
And then you gotta get out the dustpan.
Yeah.
I don't drink coffee anymore.
Well, also with the jet stream, if it basically forms at the boundary between cold air and hot air, the cold air is going to be denser than the warm air. So if it's flowing right between you and the star you're looking at, you're going to have cold dense air and hot air. They're going to refract light slightly different.
Yes.
And that's why you see the stream.
And as it wavers around, that's what causes what you're talking about.
Yeah, we can actually see the boundary layer. When it's a fairly thin boundary layer, so you don't have this huge depth of focus.
Is it, what about the Coriolis? I mean, doesn't that play around, because there's more than one jet stream.
Yeah,
You know,
subtropical
we're
and
in
polar.
latitude, there's one in the
Yeah.
southern hemisphere, et cetera. So, and they basically are predominantly west to east,
Right.
which is the direction of spin. So
Uh-huh.
it's more than just differentials of pressure.
It is, because if it was just pressure gradient, wind would always flow from high to low.
That's right.
So Coriolis.
It's Coriolis, centrifugal force, and pressure gradient force that keeps these systems spinning in called geostrophic balance.
It's kind of interesting how we discovered the jet stream.
Oh, yes.
The airplane crash, didn't it?
No, the bombers, B-29s going into Japan in the Second World War would fly into the jet stream, they didn't know it was there. And they'd end up with 200-mile-an-hour headwinds or 200-mile-an-hour tailwinds, and they didn't know what was going on. And the Japanese knew about it, but we didn't.
And it was working in their favor if it was moving from west to east.
Well, that's why they were putting in
Right.
city-air balloons.
Now, they also did some balloons. They sent up balloons into the jet stream with incendiary devices on them. And towards the west coast, and there were actually several people killed by one of them.
Really? Man, oh man.
There's actually one that we called up.
I'm gonna guess we're getting a little short on time. Is that right?
Keep going, yeah.
It's good.
Probably want to wrap up at about 9 o'clock.
Oh, okay, all right. And I'm gonna try and, this has something to do with that, and something the gentleman said at the top a second ago. So, lower part of the atmosphere is the troposphere, where all of our weather happens, but it's so tall. I mean, this has height in miles, 90 miles to the top of the thermosphere. Because of gravity, most of our atmosphere is at sea level. We have the highest pressure at sea level and the lowest pressure aloft. So that's just a good visual because I think it kind of plays into this a little bit. Before a warm front, generally you have poor visibility and pressure is falling. Behind a warm front, as that air continues to come up from the south, generally it can change. You have hazy conditions and the pressure is falling. Part of the reason you have those hazy conditions is because of what we talked about a second ago, the air tends to rush towards that low pressure system. So you're sort of collecting a lot of the molecules, a lot of haze, a lot of dust particles, pollution, etc. And it tends to be near that low pressure system and the front itself. But when we get air that comes down from Canada, even if it's cold outside in January, it's really good. It's really crisp air because you're literally replacing the air that's already here in Denver. So maybe a little bit hazy outside before it gets here, but man, those north winds take over. That dense sinking column of high pressure moves overhead. Pressure's on the rise and visibility is good. So it seems like visibility would be best after not only just a surface high, but a stacked high pressure all the way up to like 500 millibars. It starts off in the polar regions, and as I said a second ago, a very dense column of air because in the wintertime there's an absence of sunlight above the North Pole or above the Arctic Circle, and it eventually travels down. That's a really clear air mass. So for wintertime viewing purposes, I think obviously really dense high pressure from Canada.
They can stand the frostbite.
Yeah, you gotta get good gloves. Yeah. Mountain wave clouds I wanted to get into also very quickly. You guys know about these. That cloud in the background, by the way, that was near Lyman last summer. And it was a big, it produced one tornado, but it was amazing definition. You're looking up to probably 45,000 feet of cloud right there. Really cool, if it does load. Does everybody know about mountain wave clouds, or at least what they look like? Yeah. This screws a weather forecast big time. I mean, not only looking at the stars for you guys, you know, but this can be the difference between, you know, 3 and 5 degrees of temperature. So sometimes we'll blow a forecast because a mountain wave cloud came in and blocked the sun, and it ended up being cooler than we said it would. You know?
Yeah, can you plug your computer in?
Your battery.
Yeah, your battery's gonna go.
I don't think, Stuart, we brought a cord. I don't think we brought a power cord.
It was on the cart, and I thought I gave it to you when we got in the car.
I think it's in the car still.
Maybe it's still.
How many minutes do we have?
11.
11. It's okay. I'll wrap this up in time.
Well, that'll be your cutoff.
Yeah, right?
Computer dies, he's done.
Let's see here. I don't know if we have good enough connection to watch that video. It's okay. Lenticular clouds. Very cool. Estes Park, right over the Front Range, over Denver, just a big hanging blanket of a cloud. You can't see the stars, you can't see planets. It's not as warm out as it should be. They're really unique and really beautiful. I mean, look at that. That is just so cool.
That's a mountain wave cloud?
Yeah. And I can geek out on this for a second if you want to see how they do form. All right. Again, I shouldn't have erased that. All right. This is the only damn picture I know how to draw anyway. All right. So there's Denver, there's the mountains. Let's say the jet stream is moving overhead. It's they happen a lot in like November and like we're getting towards the cold season. Let's say the jet is coming in from west to east. It's coming in hot. All these mountains, we're talking about the Front Range. These are 14,000 feet. Okay? The jet stream, that time of the year, at least the lowest part of the jet stream can be about 15,000 feet. It's coming along, it's screaming along, and then all of a sudden, it hits the mountains. All of that air within the jet gets forced aloft, and then it produces these big, sometimes flat and hanging clouds, and they just stay over the city. On the east side of the mountains, it gets forced down the leeward side of the slope, and so Denver gets really windy conditions, but the benefit of the really windy conditions in this setup is that these are warming winds because they're down sloping winds. So sometimes in January, you know, the average daytime high is like 45.
The air is actually.
So this is why Boulder and places right up against the get really hammered.
Yeah, they get big wind. And so let's say the air up here, the air temperature up here is, let's call it like 20 degrees Fahrenheit. And then all of a sudden it loses 10,000 feet of elevation. It heats up along the way. And on that day, Denver will be warmer than it normally would be because of that compression.
It heats up and therefore it dries out.
Yeah.
Humidity goes down.
Exactly.
Well, if the wind is screaming along like that, why should the clouds remain stationary?
Also because, all right, so now they have no moisture source. So if these mountains went on forever,
About fast.
yeah, right? If these mountains kept going on forever, it would keep the jet aloft and it would keep these clouds up here and cool and condensing. Because we have such a dramatic drop off east of the mountains, the wind follows the terrain. And when you're not getting the clouds forming because the air is not reaching the dew point anymore, they get forced down the east side of the mountains. And then it ends up being like clear over here, like Lyman, Bennett, all that. They'll actually be in sun, but we're sort of trapped in the clouds because we're so close to the
Well,
mountains.
I've observed these, and the clouds, they just sit stock still. They do that all day long, same shape, they just sit there, and they're beautiful curves.
They are.
Yeah.
Yeah.
The air is full
Yeah,
of
the
cold.
wind is coming out underneath, the clouds are formed up high. That's probably.
So are the clouds forming on the front end and evaporating on the back end?
Yes.
So the cloud is basically.
Yes.
Okay.
Yeah.
You know, sometimes you'll get a secondary wave cloud. Sometimes you'll get that jet stream will rebound. You know, I've seen it where you get them along the mountains and then you get another one out.
And I want to correct what I just said, though. It's not evaporating, it's just, when you're looking at a mountain wave cloud, it's literally forming and dissipating at the exact same time. It's generating cloud and it's dissipating at the exact same time. So it's not necessarily evaporation, it's that the peaks are here, it's forcing the wind a lot, but then as the air gets pulled back down towards the ground, it's actually dissipating on the east side. So this is kind of like the core zone of where it forms. But the only way that the wave cloud will go away is if the jet stream moves. You know? But that's that. And that is it. That's all I got. I think I got one more. There you go.
So the important question is, you're going to put a plug in for that, so when you comment on what we broadcast.
I'm sorry?
You're going to put a plug in for that, so when you're.
I would love to. I really would love to. If I can fit it into a tornado warning or something like that, you guys are going to get a good plug. I promise.
What we need to do is talk them into bringing the multi-weather lab down to Chamberlin some night and doing one of the things at 10 o'clock. Yeah, an open house.
Or out to Deer Trail.
What's that?
Or out to Deer Trail one night. Yeah, we'd love to have them out there.
Did any of you have questions? This has been a good, fun, interactive dialogue.
Oh, good.
I've been in Denver since '70, and it just seems like the wave clouds are more prevalent in recent years than they used to be. Does anybody else feel the same way? It's just like,
No.
God, there they are.
I've lived here all my life, and it's the same. Yeah. 80 years.
I wonder if it's because more people have cameras. You know? I don't know. We're like talking about it more. Yeah, exactly.
Can I ask a question, on a somewhat unrelated, going back 20 years ago, can you talk for a minute about sprites and what forms a sprite?
I think that's still being studied. I wish I could give you a good answer. I can barely explain lightning, or as much as we understand about lightning. The fact that a sprite forms like above, like in the mesosphere or in the stratosphere, it produces this quick red flash.
Can you tell me what a sprite is? I don't know what it is.
It's basically like an upper atmosphere, I mean, it's like a bolt of lightning that's going, you know. And then as I understand, a lot of the research is being done around here, isn't it?
Yeah.
I mean, they're using aircraft to go up and photograph.
Well, they're also
things.
photographing from up in the foothills, Colorado Springs and other places. They get up higher elevations and photograph.
They also
just photograph from the space station looking down on.
Yeah.
Right, yeah. But I mean, they're fascinating.
They are.
Which I understood it.
Yeah, me too.
Scientists wish they understood.
Sorry, I didn't mean to.
No, more about it too. They're rather interesting phenomena. There's if I recall, there is some indication that gamma rays are a byproduct of some of these things.
Yeah. You know, satellite measurements, they've measured gamma radiation over thunderstorms.
So there's interesting phenomena.
Think of lightning bolts as carrying charge from a positive region to a negative region. It could be cloud to cloud or cloud to ground. But these sprites, they kind of go up to nothing, it looks like.
Well, they're a fairly recent, they were first seen by accident, right? And it's fairly recent, in the last 10 years.
Yeah. Oh, yeah.